These are the instructions for the Gear for Solar calculator. This Excel spreadsheet automatically calculates battery, solar panel and inverter sizes for your motorhome, boat or other off-grid installation. This calculator is meant to simplify solar for competent persons building DIY or allow unqualified users to show consistent requirements to contractors. OK, sample data is already entered to get you started. Simply replace the current values in the cells that are pale yellow with your own data here and here. Do not edit any other cells. Work your way down the page. As you enter your data, you will see other values elsewhere on the sheet are recalculated. Note that you can mouse over the little red triangles to see tooltips with useful advice. The first step is to enter a list of your devices in the table under the Devices heading. Once you have entered the name of the device in the description column, enter the wattage. Be as accurate as you can. You may need to look up the wattage for each appliance from its user manual or from a specification plate fixed onto the item itself. If we just assumed that we ran our appliances all day, we would end up oversizing our batteries and panels, which is expensive and space intensive. So, we should make an allowance for how many hours per day you expect your devices to run. Have a think about how long in hours per day you will realistically operate each device. In the sample data, you will see entered a small 12-volt fridge runs constantly, whereas the 230-volt microwave is only used for 3 minutes a day. In a typical motorhome or boat installation, you will use a mixture of 12-volt and mains appliances. The distinction is important because you can save money on your inverter. Only your mains appliances need an inverter, which can be an expensive bit of kit. The next section calculates the size of battery required to power your loads. It is assumed you will use 3.2-volt lithium-ion phosphate cells connected in series to create 12-volt, 24-volt or 48-volt systems. No battery is 100% efficient, so we need to take that into account for our calculations. 90% is typical for deep cycle lithium-ion phosphate bank charge-discharge. Unless your location is in the sunbelt of the southern US or Europe and it is summer, your system will not be 100% charge efficient. How many cloudy days off-grid you expect to rely on the system with no or reduced sun must be taken into account. How long you can remain autonomous is also dictated by how many sun hours per day you can expect. Average solar hours per day are determined by your latitude and time of year, which may take a quick Google to look up, but you can leave that at 5 for now. And that is it. The calculations are shown on the right in the results area. This calculator is regularly updated with increased functionality, so subscribe and ring the bell to be first in the queue when it is released. If you spot any mistakes or improvements you would like to see, let me know in the comments below.